Welcome to the project demonstration of CAN-based intelligent driver assistance system. So here we are providing the assistance with the help of two sensors. One is the all-call sensor in order to prevent the drunken drives, and eye blink sensor to detect the drowsiness of the driver. So whenever he is sleepy or drowsy, then we need to intimate to the driver to avoid the accidents. So these two sensors intention is to avoid the accidents and to assist the driver. And the communication from the master section to the slave section will be done through this CAN protocol. So we are using the CAN ICs which will communicate between the transmitters, that is nothing but a master and a slave. Slave consists of GPS, GSM, LCD display, buzzer for audible alerts, and DC motor which representing as a ignition unit. So main application of the CAN is nothing but when we are communicating between the n number of modules to the slave system, then we need to use the CAN protocol. Then only we can communicate through the only two wires. So that is CAN low and CAN high. So serial communication can't applicable for two-wire communication. There we need to interface the each and every module to the different pins. But in coming to the CAN protocol, so we can connect the n number of slaves here, like we are going to send the data from the slave to the master, which will control the based on the input, and it will controlling the ignition as well as sending the message alerts and displaying the status on the LCD screen. So here this slave is sending with sensors data whether the person is drowsy or all-call detection. So all are interfaced to the PIC microcontroller, and from there to the CAN IC, and from there CAN decoder, and from there to the again PIC microcontroller. So here we have interfacing the connections GPS to the A0, and D1 for the DC motor, and D2 for the LED as well as buzzer, and C6 C7 for the CAN high and low, B0 B1 for the GSM module, and B2 to B7 for the GPS. At this section, eye blink sensor interface at the pin number A4, all call sensor interface at the pin number A0. So the main input and output connections of our project. So here before demonstration, we should keep the kit under the sky view, then only the system will get the satellite vision for the GPS module. When we get the satellite vision, there we can get the light indication on this GPS module, and it will show the live location values, that is latitude and longitude values. If we demonstrate this kit under the sky view, there is no satellite vision for the GPS. It will provide us a 0 values in terms of latitude longitude values in real time values. So before demonstration, first step is keep the kit under the sky view. We are demonstrating under the roof, we will get the 0 values, and the second step is insert a valid SIM card into the GSM module. So it should be in this manner. If it is nano SIM card, the notch should be this side, and after inserting that, gently push and lock. Then you can see that it will be locked. Now on the power supply for the master, and thereafter to the slave. Right. So after we switch on that slave, this one is a slave, so n number of slaves will be present. So in our project we are demonstrating with the driver assistance, and we can place the engine sensors and the speedometers and pressure sensors. All this can be monitored from the master and the slave. So we are using only one slave. We can use a number of slaves and one master. So now, as of now, everything is normal. One LED indication, it's normal, and the second LED got switched on, it's abnormal. So now on this, coming to this one, I will show you again. When we on the power supply to this master, initially this light will blinks very fast. Right. So when the SIM card got the signal, its blinking rate will be slowed down. Right, now it is slowed down, right? Then for the confirmation and safety purpose, just restart this one. After SIM card got the signal, restart the microcontroller motherboard with the help of this switch. Now init was successfully done, and 0 as we discussed, it's showing the 0 values. As of now we are demonstrating it indoor. So coming to the all call sensor, right. So as this marker consists of alcohol, so it will send the, you can see the light indication on this alcohol sensor. As you can see, alcohol detected. So if any communication delay occurred, just restart this motherboard, master motor. As you can see the and also message alerts will be sent to the registered phone number. Right, so this is a message we can receive, all call detected, and a vehicle is at so and so location. And coming to the drowsiness detection, when the eyelid closed here, for 2 seconds of duration, if it's continuously closed, so there we can see the message alerts on the LCD screen, along with actually the motor got ignition off, and reset that. In order to make it on, we should reset the motherboard, then the ignition will be switched on again. Then we can demonstrate for eye blink sensor. Right, after 2 seconds continuously eyelid closed, then we get the buzzer alerts and sending SMS alerts. So this is a message we have received for the driver drowsiness detection. Right. Thank you.